Hey everybody, so today I'll be showing y'all how I analyzed some data on different upper extremity injuries from a bunch of different patients from a fictional athletic training clinic. So looking at this data, you can see the different kind of outcomes or values that we obtained were going to be the injury severity, time lost, global ratings of pain and function, as well as some more specific outcomes that we see over here, the DASH and the CKCUES. So the DASH is going to be the disabilities of the arm, shoulder, and hand index. So we have day 0 or day of injury values and return to activity values, as well as the closed kinetic chain upper extremity stability test scores. We have baseline scores, post-injury scores, and return to activity scores. So looking at all of our data, what piqued my interest here was the large range of time lost for the different injuries depending on the severity. And if you take a look, after I sorted the data from mild, moderate, and severe, you can see that it doesn't really correlate with the different kinds of structures injured, the age, sport, or gender. The injury severity and time lost correlate well, but it doesn't really correlate with any of these. So that was kind of interesting to me, and I wanted to kind of investigate a little more on what else I could use to classify injuries as mild, moderate, or severe, depending on the rest of the values that we obtained. So first I wanted to get an idea of the different types of upper extremity injuries that I was dealing with and the amount of each type. So if you have a small data set like I do, you can just go and count them. But if you have a larger data set, you can use the count if function to come up with the different numbers of each injury that you have. And then from there, I calculated the percentages in a pie graph here. As you can see, most of our injuries came from labrum and tendinopathy pathologies. The others came from rotator cuff, different ligament sprains, and we have one bursa injury. So after, like I said, after sorting the data from mild, moderate to severe, I wanted to see what other trends I could find in the rest of the values. And whenever you take a step back, you kind of think about when you're evaluating someone, what you look for to determine if an injury is going to be mild, moderate, or severe. So that's going to be their pain scale, their loss of function, and if you have baseline scores like we do, you can compare that to a post-injury score. That was the first thing I did, was look to see if there was a change in the baseline and post-injury and return to activity scores. So you can see there's a bit of a change in the post-injury score. I really wanted to see if there was going to be a change from the baseline to the return to activity, because I don't know much about the closed kinetic chain upper extremity stability test. And it looks like when return to activity, most of the patients got close to, if not at their baseline, or just under it. Another value that I wanted to choose just to kind of demonstrate I guess, how somebody's function or pain can change with a mild, moderate, or severe injury. So I chose the global rating of function to kind of demonstrate this. And the global rating of function is basically how someone is functioning on a scale of 0 to 100%, or 0% being that they can't function at all, and 100% being that they can do anything they want to or need to successfully and without pain. So the first thing I did after sorting my data was to kind of run a average on the global rating of function for each mild, moderate, and severe category, and then find the standard deviations of those as well. And the best way that I could think of to kind of chart this was with a scatter plot that I have down here. So to kind of explain what you're looking at, each diamond is going to be a patient. And since I already had them sorted from mild to moderate, that's how they're appearing on the x-axis. And then on our y-axis, we have the global rating of function in terms of the percentage from 0 to 100. I went ahead and on the y-axis put a marker for what the average was for mild, moderate, and severe. Mild, this red square, moderate, this green triangle, and this X down here being severe. And then using the standard deviation, I came up with these kind of zones to show you where a mild, moderate, or severe injury would fall. So basically, if the average of a mild injury is going to be 81.2% functional, if you will, and give or take 12% is going to put you in this green zone here. Same thing with moderate, around 58.3 is the average percent of how functional a patient's going to be with a moderate injury, give or take 12.1%, putting you in this yellow zone. And then severe at if they're 19.4% functional, give or take 12.9, putting you in this red zone down here. So this gives you kind of a nice little visual of a showing both the correlation between severity and functionality. And I would imagine you could do the same thing for pain or for our DASH scores or other outcome measures. You would see a similar trend, this kind of downward correlation. And the different zones that you have also were pretty useful in helping to determine where someone would fall if you asked them, you know, on a scale of 0 to 100%, how do you feel like you can function? How do you feel like your daily activities are going? And if someone tells you, you know, oh, I'm feeling pretty good, I'm around 80, 85%, you would be like, oh, well, okay, that's a mild injury, versus someone who's like, man, I can't, maybe 20, 25 is going to put them in this severe category down here. And after that, you can kind of take that information and come up with a plan of care. So oftentimes, especially when I'm evaluating patients, they always want to know, how long am I going to be out for? How long is this going to affect the fact that I can't play football? Or how long is this going to keep me from getting back to work like I used to be able to do? And to give a patient a good answer is always kind of tricky because every patient is different. So I wanted to see if I could kind of do the same thing, take our mild, moderate, and severe categories, if you will, and then see what the average time lost is and the standard deviation that went with that as well. And I put that in this kind of bar graph that you see down here. So for a mild injury, the average time lost was a day or two, give or take half a day. For a moderate injury, around 5 days, give or take 2.5, so a few days up to a week. And then severe injuries, it was a very large standard deviation. So for severe injuries, it really does vary, but the average was 28 days, so rounding about a month. But like I said, the standard deviation was large, so for a patient with a more severe injury, that answer would be a little bit harder to give because, you know, every injury is different, especially when it comes to the severe category. But a patient with a mild injury, you can confidently give them that answer of, this shouldn't keep you from doing your daily activities for more than a day or two, unless it's falling into that kind of gray area that you see here. Then they might keep them out for a few days up to a week. But I just found that kind of interesting to analyze this data and then see how I could kind of relate that to a real world situation of using that in my evaluation process to kind of categorize their injury as mild, moderate, or severe, and then helping that dictate my plan of care of how long I expect them to kind of be out with this injury. And that can help me with my goal setting, give me an idea of where I can start my treatment and rehab, and different things like that. So thanks for watching, and I hope my kind of data analysis that I had here was interesting for you. And thanks for watching. Have a good night.